Good good evening. Yeah, let's start. So, in the last class, we discussed the conversion finite automata to Adam's theorem using Adam's theorem, regular expression construction, and state elimination method. So, that two method we discussed to create a regular expression. After that, we solve some question. So, as we already discussed, to solving the question, there is no need to use any method, just directly solve by rejecting the options. So in this manner, we solved this questions in the last class. Some question that we discussed already. Now some more question, two, three. Let's complete it. So this is the question. Consider the following NFA. That is the given NFA. What is the regular expression for this? Out of this four option, which one is the regular expression for this given? Again, the same logic you need to use. Try to eliminate the options. You get the right answer. So please check for this. What is the right answer? Yes. Which one is right? Again, the logic is same. We start from what? Minimum length string. So first check what is the minimum length string that accepted by the given regular expression. What is the minimum string that accepted by the given regular finite automata? So here the finite automata is this. So null is accepted from this. It's clearly visible because initial state is final, so null is accepted. Now, out of four option, which one is generate null? So it is clearly visible that every finite automata has same regular expression in the first part, 1 plus 0 0 star 1 1 whole star. It is like that. So this four option contains same part, and that whole star will be there. So definitely from this part we can generate null 1 1 whole star. So we can generate null from this part. Got it? Null is possible from this part. And from the second part here, in the first option, null is directly visible, null plus 0 0 star. So we can take null from this expression. So definitely that will be completely, we can say that null is generated. Now here, in the second 0 0 star, here we can say that from the second option, the minimum string is 0, from this pair 0 1. Means either we need to take 0 or 0 1. So the minimum string from this regular expression is what? 0. If we put completely null to first part, and from this part if we take 0, then this is the minimum string. But null is not generated by second option, so it is rejected. Now, in the same manner, null and null is generated by C and D both. So, A, C, and D, out of this three option, any one may be right answer. So, B option is rejected here. Now, let's try to understand the remaining A, C, D option. So, here the first part is exactly same. If we compare that, here it says that null plus 00 star plus 00 star 1. It says that null plus 00 star 1. Here is null plus 00 star. So it means what we can say, that both the expression of option C and D will be present here in option A. So first we try to check the string generated by any expression part of this expression, like 00 star. So it may generate any number of zeros. Got it? It is generate single zero, double zero, triple zero, any number of zeros. Got it? So that all zeros can be accepted. So can we generate all zeros from the option? We can be accepted number of zeros from the given NFA. So yes, from this initial state, if we take zero and read any number of zeros, that will be accepted. Means what we can say, that any number of zeros can be accepted by NFA. The first option, generate any number of zeros from this regular expression. We are just ignoring the first part. Why? Because it is same in all option. So we directly consider the second part, because from first part we can take null, just put null and we can generate. Now here from option C, if we try to generate any number of zeros, so it is clearly visible that for this one is compulsory. Means any number of zeros and after then one is compulsory. Means only zero cannot be generated by this automata. We can say that single zero is not generated by option C, but single zero is accepted by this. Got it? So C is also rejected. Now here it says that in this part, if we can say that key string, if we try to generate single one, means first we take null, and by this null we reject the option B. Now for a string 0, we reject the option C. Now if we want to generate single one, so it is clearly visible that any number of one can be accepted using this loop. So single one, it is clearly accept generated by first part, because it is 1 plus 00 star. Now we can see here in this option D and option A, there is only this regular expression is not present in option D. So what type of string can be generated by this? Means we consider any number of zeros and single one. So this type of string is accepted by automata. Yes, any number of zeros and single one. But this type of string cannot be generated by option D. Got it? The option D cannot be generated because here is only what 00 star, and after then one is not present. If we take this part, then it generate only number of zeros and last is 2 1. But single one cannot be generated. After number of zeros, single one cannot be generated. So option D is also rejected. A is right answer. In this manner, you can reject the options and get the right answer. Got it? So this is the approach, what? Finite automata to regular expression. Got it? Finite automata to regular expression. Now here it says that consider the DFA. There is a one DFA, 7-bit binary string in which first, fourth, and last bit are 1. Means we need to design 7-bit binary string, 1, 2, 3, 4, 5, 6, and 7. Out of the 7, first, fourth, and last bit is 1. Then number of string that are accepted by this, means in second, third, and fourth, fifth, sixth position you can put any bit 0 or 1. After putting that, that string is accepted by this DFA or not. So how many string? Same pattern question we already solved. That is a different question. This one is different. Try this one. After then we start the concept of regular language. In second position, third position, you can generate 0 0 or 0 1. Means here 0 or 1, 0 or 1, 0 or 1, 0 or 1. So four places are there in front of you. So total eight different string possible. Out of that eight, how many is accepted from this DFA? That is the simple question. Let's see. It is clearly understandable that what we can say that, let's here. So here 1 0 1 0 1 option is there. So let's how to solve such type of question. It is clearly visible that first one is obviously read by this, that will be the loop, and after then we take 0 0 and 1 and we reach to the final state. So first try to generate that type of a string. So 1, this one is fixed. Now here we have option, we can take 0 0 and after then 1, that is fixed. Means if we put 0 0 in these two places, then 1 0 0 1, after reading this string 1 0 0 1, we already reached to the final state. Now after then what we can say that there is a loop of 0 1, means anything you write down here in these two places, that will be accepted, because every bits can be accepted by final state. Means either we return 0 0 1, that is accept, 0 1 1, that is accept, 1 0 1, that is accept, or 1 1 1, that is accept. Because in these two places, four choice, 0 1 0 1, 0 0 0 1 1 0 1 1, all will be except, because we are already at final state after reading this inputs. So how many states? Four state are there. Four state. Got it. Four states are there. Means four strings are there. So this four string is directly accepted. Now if we change 0 0 in place of this 0 0, if we change the input, so like after 0, if we put 0 1, means this two one are fixed, this last one are fixed. Here we just pick 0 1. So from 0 0 we take four different strings. If we put 0 1, so after reading this 1 0 1 1, that's it. Means after reading this 4 bit 1 0 1 and 1, so we stop at initial state. Now to reach final state we required 0 0 1. Means after then we need to fix 0 0 here, then only we reach to final. That means this is the next string, that one the string is accepted. If we put 1 0 here, then what will happen? So if you put 1 0, so that is double 1 0 1. So double 1 0 1. This is the 4 bit end to the initial state. Double 1 0 1. Again we need to read 0 0 1, then only we reach to final state. So this is the next string, means 4 5 6. Till now 6 strings are there. Now if we put 1 1 here, that is also what, all four ones. So all one accepted by initial state, and after then we put 0 0 1 only, that is accepted. Means here what we can say that that is also one string. So 4 5 6 7, seven strings are possible. Seven different strings are possible only. Got it. So out of eight combinations, seven are accepted here. Okay. Now Let's see this type of question. What is the question here? Consider the finite automata in which following figure is there. What is the set of reachable states for the input string 0011? Means if we have this string 0011, so out of this four, which of the following are reachable? Means on the initial state q0, from initial state if we read 0011, so after reading this complete string, how many states can be reachable? All right. So because it is NFA structure, that's why more than one output state possible. So if you read all 0 and 1 on initial state, then you can end on same state. First 0, second 0, third one, fourth one. All will be read. So reachable state is what? Q0. So Q0 is also reachable. After reading complete string, we can end to the Q0. So that is the first reachable state. In the same manner, you need to find all reachable. So what is the possible states? Just find out. First reachable state is Q0. Other than that, so it is clearly visible from Q0 on input 0, there is a loop of 0. Means first two 0 can be read on Q0 only. On Q0, we read first 0, second 0. Both 0 will be reading on the same state. After then on this input 1, we can say that on input 1 we can reach to Q1, and after then on input next one we can reach to Q2. Means 0011 reach to Q2. So Q2 is also reachable. In the same manner, if we read first three input on the loop, means 001, because it is a loop of 01. So first 0, second 0, and 1. This three string is reading on Q0. And for last one, we can end to the Q1. So Q1 is also reachable. Now, any possibility to reach to Q3 state? So definitely it is not, because first to 0 we need to compulsorily read on Q0. After then, first one, second one, we can end to the Q2. But for Q3, we required minimum 3 1. So that is not possible. So only three states are reachable: 0, 1, 2. A is right answer. A is perfect answer here. Okay. Okay. Now, so that is the some questions that we discuss, that all are PYQs. Now here we start the next topic of related to the regular language. Means we are in the regular family, as we already discussed that in the regular family, four different topics: regular language, regular grammar, finite automata, regular expression. So we already understand the concept of regular expression. We already find the conversion. Means here we finite state automata to regular expression. This part is done. Now the second one is regular expression, or we can say that NFA to DFA conversion. That is also complete. Right. And regular expression to finite state automata, we already understand how to construct this. Minimization of finite automata, that is also complete. Got it. So this topics we already convert. NFA to DFA, NFA with null to DFA, regular expression, minimization. These topics are done. Now here we need to start the new, that is regular language. Alright, so next is what? Regular language. So what type of question ask on that? Because this is very important and various questions are asking on this topic, that regular language. So actually what is regular language? So regular language means, if one language in front of you and someone asks that the language is regular or not, such type of question is asked, the language is regular or not. So how to check that the language is regular or not? So to check that the language is regular or not, either what we can say that either we can construct the automata for that language. So the language is regular or not. So what we can say that either we can construct the automata for that language, or we can define one regular expression for that language, or there is a we are able to construct finite automata for that language. So if we are doing any one thing out of this three, then we can say that the language is regular. So what we can say that language is regular if if there exists regular expression, if there exists regular expression equivalent to equivalent to that language. Means for that language, if there exists a regular expression, or there exists regular grammar, or there exists finite state automata. There exists finite state automata. So actually, if you are designing any one of these three, then you can say that the language is regular. So regular expression, regular grammar, finite state automata. Why we can say that any one of them? Because conversion is possible. From regular expression, we can convert to regular grammar. From regular grammar, we can convert to regular expression. From regular grammar to finite automata to regular grammar. Every type of conversion is possible. So if you construct any one of them three, then you can design the remaining also. So in this manner, we can orally directly says that the language is regular if there exists any one of these three for that particular language. Got it? Now, one more point here, we need to understand that there are two different way to check that the language is regular or not. So here actually there is a one shortcut, or we can say that there is a one trick from that we can understand the language is regular or not. So what is that? We need to understand that. Let's see, if we have a grammar language, L equals to a raised to n is greater than equals to 1, and we need to check that this is the regular language or not. Is this language is regular or not? So is this regular? Can we construct the finite automata for that? Or be able to construct the regular expression? Can we construct the finite automata or regular expression? Anything? So we know that n is greater than equals to 1. Just write down means it generate the set of string is what? Single A, double A, triple A, and so on. We already understand this type of string is what? Means it will generate all the A's. So regular expression is what? A plus. So regular expression is exist means we can say that this is the regular language. Okay. Or we can directly understand minimum string is single A, after then any number of A is except. So this is the regular finite automata. So this is the finite state automata for that language. Again, we prove it is a regular language. We can construct the grammar like A S A. This is the regular grammar. From starting variable, we can generate single A, and from this expression, we can generate any number of A's. From S we can call as any number of times. So all of these three are possible to construct. There is no need to construct all of them. You just understand that any one of them, if you are able to construct, or you think that yes, I am able to construct, but right now at that particular time we are not able to completely construct the automata, but we know that yes, automata is possible, then we can say that it is regular. Okay, so this one is regular language. If we write down any pattern like languages, let's see here, I just write down L equals to a raised to n, b raised to n is greater than equals to 1. Is this is the regular language? Just tell me, is this is the regular language? Can we construct the regular finite automata for this or not? And how many states for that? So first check that which type of string is generated by this language. So if we write down L equals to, in place of n, if we put 1, it is what, a raised to n, b raised to n. So in this particular language, if we put n, value of n is 1, so that is what ab. Put the n, value of n is 2, then double a double b. Value of n is 3, then triple a triple b. So it means what? It generate all the string in which equal number of a's, equal number of b's, and all the a's will be present before the b's. Got it? So this is the condition of this language. Now can we construct the automata for this? So actually this language required what? Dependency between the input. Means initially you need to read all the a's, and after then you need to read all the b's. Now the condition is what? The number of b's should be equals to number of a's. So if it says that like it is, if it says that the regular expression like this, a plus b plus, got it, value of n is greater than equals to 1, so if you put plus plus in place of n, so this is the regular expression. Is it correct regular expression? So definitely it is not correct regular expression. Why? Because there is not any dependency between the plus. This both plus can be grow independently. Means if I put the value of this plus is 1, and if we put the value of this plus is 2, that is also correct. But here is what n, and n is what? The single variable. So if you put the value of n1, then that will be put in both place. If you put 2, then it will be in both place. But here is what? Plus plus. So this is independent. So what we can say that this plus and this plus is independent. And this n and this n is what? Dependent. So definitely this is not regular expression for this. As we says that again, if we try to construct the automata, so what we can say that the minimum string is what? AB. So AB, so first A and B, for this we accept this string AB. Now as we says that first A, and after then we read the number of A's, when we B we read the number of B's. So all the string of this set will be accepted by this automata, because the first AB accept, double A double B accept, 1 2 3 A's, 1 2 3 B's accept. But it also generate unequal number of A and B's. Means if we read A double B, so A B B, that is also accept. Means it generate all the string of this regular expression. So this is also not a correct finite automata. In the same manner, we are not able to construct the regular grammar also. So how to check that? So let's understand the point is what? If the language contain dependency between the inputs, or we can say that if there is a dependency between the input or it required a memory. Means finite automata is what? It is a memory less device. We have not any extra memories. The logic of this language is what? First we need to store all the number of s. Means it says that if we apply the condition on this loop is what? That loop run three times, then this loop also run three times. But we are not able to apply restriction on this loop. All right. According to this language, we need to first read out how many a's are there, and after on then we need to read only that number of b's. So for that we required extra memory. But finite automata is memory less device. So fsa is memory less device. Memory less device. What is the meaning of this? Means there is not any extra memory. Not any extra memory to store input. To store input. Alright, so we have not any extra memory. The only the automata is there. Other than that, nothing is there. So finite automata is memory less device, and there is not any extra memory. So if any language required extra memory, that language is not regular language. So for this language, if we explain this language is what? A raised to n, b raised to m, n is greater than equals to 1. So here what we can say that number of a's or number of b's should be equal to number of a's. Means input b depends on a, means input b depends on a. So if there is any type of dependency, if there is any type of dependency between the inputs, then that language, yeah, we just complete the statement in this manner. If there is any type of dependency between the input that required extra memory, that required extra memory that required extra memory, then that language is not regular. Then that language is not regular. This is the first case. This is the first case in which we can say that that type of language is not regular. So here this language is not regular. L equals to a raised to n, b raised to n, n is greater than equals to 1. This is not regular. Got it? So this language is not regular. This is not regular. Got it? Now in the same manner, if we take one more language, L equals to a raised to n, b raised to m, n is greater than equals to 0, m is greater than equals to 0. Is this is regular? Just reply. If you have any doubt, you can ask the question. Please reply. Is this is the regular language? How to check? You need to check that any dependency between the input or not. Is there any dependency or not? So first you check that n is what, greater than equals to 0, m is greater than equals to 0. So if we put 0 in place of n, put 0 in place of m, so that will be generate null. After then what we can say that because it is this n or m is what, independent, its range is different, means it will be run independently, it will be run independently. So if I put 1 in place of n and 0 in place of m, so it will generate single a. If we put 0 in place of n and 1 in place of m, so it will generate single b. If we put 1 in both place, it will generate ab. Is what we can say that it generate all the strings in which beginning contain s and end contain b's, all s and then all b's, but number of a and b is not required to equal. Okay. So what type of regular expression we can construct here is just try to check every input. For every input you need to understand what that regular expression is what, because the range of n is what, greater than equals to 0, so we can put here a star. The range of m is also what, greater than equals to 0, so that is also a star. So here a star b star, and that a star b star means what, that is a regular expression definitely, because this two star are independent, as we already says that plus are independent. In the same manner stars are also independent, and here n and m is also independent. Got it? That is independent. So we can say that this is the perfect regular expression. And for this regular expression, if we are able to construct regular expression, means the language is regular. So this is the regular language. So what we can say that null is accept. After then a star. So a star means we make a loop of a here. Now for b star, take an input b, reach to the next state and apply the loop b star. So a star b star. This is the regular finite automata. That's it. So this is the regular language. In this manner you can understand. So this is the regular language. Got it. Now, if we, I just give you one more example. Like the language L is A B, double A double B, triple A triple B. This is your language. This is the complete language. Is this is regular or not? Yes or no? Is this is regular or not? Actually, this is what in this language what it written A B double A double B and triple A triple B. So all these three string contain equal number of A's, A and B, number of A and the number of B. Okay. So in this pattern here, but the language is what, only three strings are there. So this is the finite language. Alright, this is what finite language means. If number of string is fixed, countable, that is finite. Here what we can say that this is infinite language. This is infinite. This one is also infinite. So if the language is infinite, then that may or may not be regular. Means this infinite language is not regular, and this infinite language is regular, as we already construct here. Got it? So language is what we can say that infinite. So may or may not be regular. But if the language is finite, then that is always regular. So there is no need to check what is the string. Just say yes, it is regular. Always regular. Okay. So here this is 100% regular. So how to construct? So what we can say that the first string AB. So you need to individual string that AB is accept. Now double A double B. So first A, second A, and here what we can say that double A double B. So second B, first B, second B means AB is accept, double B is accept. For triple A you need to make one more direction. So this is triple B. So AB double B triple B. If such type of statement are in front of you, so you need to construct in this manner. So this is the finite automata that accept this three string only. That's it. So what you write down the statement, every finite language is always regular. All right. Every finite language is always regular. Every finite language is always regular. But regular language, regular language is not always finite. That is very important statements because on this statement, number of theoretical question are asking in the examination. Okay. Already many question already asked in the gate. Okay. So every finite language is always regular, but regular language is not always finite. Okay. So that is the statement. Means this is the regular language, this is finite. This one is regular, but this is infinite. So regular language may or may not be finite and finite, but finite is always regular. Now, I just give you one more example. Like if we write down in this manner here, any number of a's, like if we written here l equals to a raised to n, okay, a raised to n summation, or we can say that in this manner, a raised to n x a raised to n, and where x is what, a comma b whole star, got it, a comma b whole star. So is this language is regular? L is a raised to n, x a raised to n, x belongs to a plus b whole star. Means in place of x you can put any string of ab, before x any number, n number of a's, and after x n number of a's. Means that n is variable whose value is what, greater than equals to 1. You can put greater than equals to 1. So is this is regular or not? Is this is regular? Just reply. Okay, so how to check a raised to n x a raised to n? So again, what, according to this statement, number of a's is here and number of a's are here. Got it? So that is equal number of a's, but we can write down the string like a raised to n x a raised to n. So in place of this x, what we can put, a plus b whole star a raised to n. Now you can break this statement like a raised to n. So first input a into a raised to n minus 1. Means we just break a raised to n into two different parts. A and a raised to n minus 1. This a plus b whole star as it is. In the same manner, this last part is a raised to n minus 1 dot a. Means here actually between this number of a's in front and end, we can generate the any number of ab in between that. So if we break this a raised to n into in this two part, a into a raised to n minus 1, we can write down this both are equivalent. So if we says that this complete number of a's can be generated by this loop, we can merge this number of a with this loop. So if we merge this, so this will be equivalent to what, this part. Got it? And this is what regular expression. We can design the finite automata for that. Let's see here that a last is a raised to final, and in between we can read any number of ab. Start and end with a. This type of language is this. So how it is possible? Let's understand. Actually, every string that generated by this language will be accepted by this, and every string generated by this automata will be also part of this language. How? So it is clearly visible. If you put value of n is 2, so double a x double a will be generated by language. Not it, double a x double a. Now x is what? A plus b whole star. So double a plus b whole star double a. If we put value of n is 2, then this string will be there. So is this string is accepted by this automata? Yes. First a, now second a is read by loop. Every string generated by this is accepted by this loop. This a is accepted by this loop, and last a will reach to the final state. Okay, so it means what, it is accepted. Now if we generate the string from this triple a b a, like this is the string, first a, second a, third a, b, up to b, all the string will be accepted by loop. This is the loop, this is the first a, and this is the last a. So we can say that if we put the value of n equals to 1 in language, then we can generate this string. So why it is possible? Because in between there is a loop. Got it? Okay, no issue, Avik. Try to connect. Is my audio? There's a network issue from my side, or is the audio video is not clear? Okay, so in this manner, what we can say that this is the perfect regular language. You can construct the automata, means this is the regular language. There's no need to check anything else. Okay. Okay. So this is regular language. Now, I just give you some more languages and just tell me it is regular or not. L equals to a raised to n, b raised to 2n, n is greater than equals to 1. Is it regular? Is it regular? Actually, here what says number of A's and number of B's are what? Number of B's are just double than number of A's. Number of B's are okay. Now it is clear, na? So as we already discussed, this language is regular. A raised to n x a raised to n. This is regular or not? So clearly visible that is not regular. Yeah, this is not regular because number of B depends on number of A. So directly you can say that not regular. Now, if we write down L equals to A raised to n, B raised to m, n is not equals to m. Is it regular? N is not equals to m. So as we says that number of A should not be equals to number of B's. Means number of A and B should not be equal to each other. So for that also we require the dependency. Means first number of A will be count, and after when number of B will arrive, then we need to check that number of B should not be equals to number of A. So for that also we need to require extra memory. So it is also not regular. So number of A is equals to number of B or not equals to number of B. For in both case we required extra memory. That's why the language is not regular. All right. So that is the concept here. Now sometime the expression will written like this: a raised to n, b raised to n is less than equals to 4. Is it regular or not? Is this is regular? Yes, because here n is less than equals to 4. So value of n is less than equals to 4 means it will become a finite language. The number of n is what? The value of n is either 0, 1, 2, 3, or 4. Alright. Means if you put 0, then it will be null. If you put 1, then single AB. If you put 2, then double A, double B. If you put 3, then triple A, triple B. If you put 4, then 4A, 4B. So only 5 strings are generated. So that language is what? Finite. And finite is what? Regular. So this is regular. This language is regular. So sometime the limit is in place of greater than equals to, it write down less than equals to. So just read carefully. And after reading carefully, that you just give the answer. Otherwise, it may be wrong. So this is regular language. Okay. Now that L is equals to, here we write down that is A raised to n, B raised to n, C raised to n in this manner. If you just increase the number of inputs A, B, C. So here n is greater than equals to 1. Means what? Number of A equals to number of B equals to number of C. So is it regular? Definitely, because now the dependency between A, B, and C, all B depends on A, C depends on B. So definitely it is not regular. That is not regular. Not it. So that all questions that we write down here, that will be asking in the 8th examination. The combination of that question will be asked. Just write down one by one every. Now here, if you put L equals to a raised to 2i. I is greater than equals to 0. Means there is an input, only single input a, and the power of a we put 2 into I. 2 into I, value of I is greater than equals to 0. So is it regular? Is this language is regular? Is this language is regular? If you put the value of I here, so value of I 0, then it become what? Null. If you put value of I 1, then it is double A. If you put value of I 2, then it become 4A. If you put value of I 3, then it becomes 6A. So what is this? That create all even number of A's. Means you need to understand when there is a single input, because this is very simple example. But the logic is what? When there is a single input and we need to check the language is regular or not. So you just take the series of that input and check there is any common difference between the length of a string or not. So here is what? 0, 2, 4 length, 6 length, then 8 number of a's, 10 number of a's. So the difference this in the series of different length of a string, the common difference is what? 2. Is between 2 and 4 differences 2, 4 and 6 differences 2, 6 and 8 differences 2, 8 and 10 differences 2. So if the common difference is fixed, then that is 100% regular. So this is what regular language. This is regular because even number of a's, the difference, common difference is 2, so you need to make a cycle of 2 to construct the automata. Like, let's see. The null is accepted, single A is reject, double A is accept, third A is reject, fourth accept, fifth reject, sixth accept. So all even number of A is accepted here. This is the finite automata. So here the loop of 2 is there. Now in the same manner, if you write down here, A raised to 3i, I is greater than equals to 0. Now we just put 3 in place of 2. Is it regular or not? Just put 3 here in place of 2. Is it irregular or not? Or if it is regular, then what is the common difference? So clearly visible. If you put 0, null. If you put 1, triple A. Put 2, 6A. Put 3, 9 is. Got it? So 0, 3, 6, 9, 12. So the common difference is what? 3. The difference of 3 is there. Yes. So 3 is the difference between the inputs. Means that is a regular. We need to make a cycle of 3. Null is accept first A, second A. On third A, we return back to the final state. So this is the cycle of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So on every multiple of 3, it will be on a final state. So this is regular. This one is regular. Got it. So in the same manner, if you put any multiple, means 3, 4, 5, 6, if you put any this type of language, a raised to 2i, 3i, 4i, 5i, got it, that all are regular. All are regular. That's it. Got it. Now, in all cases, what we can say that I is linearly run, means I is greater than equals to 0, greater than equals to 1, greater than equals to 2, because here it is greater than equals to 0, so minimum string is null. If it is greater than equals to 1, then minimum string is triple A. Means the number of state will change in the automata, but the language is still regular. Got it? So it is like that. Okay, so that if I just write down the question is other than that regular language. If I just write down that a raised to, that is 3i and I is greater than equals to 2, then how many states are required in the DFA? Just tell me how many states are required in the finite automata or DFA. Because the single input is there, so whatever structure you make, that is 100% DFA. Yes. How many states? Actually, you need to understand the minimum string. You need to understand the minimum string. So that is what triple. If you put the value of I is 2, then it become what? 6a. But after 6, what we can say that it will be linearly run. So after 6a, it will be next is 7a, then sorry, next is what? There is a difference of 3. So if you put the value of I is 3, then it will become 9. Value of I is 4, then it will become 12. Means the common difference is still 3. So how many states? So that is first a minimum string. For minimum, you just make automata. 3, 4, 5, and 6. So the 6a, that will be accepted. That 6a will be what? Accepted. So first, second, third, fourth, fifth, sixth. Because for 6a we required the 7 states. Now after that 6, 7, 8, 9, we can say that 7, 8, 9 will be accept, 10 will 12 will be accept. So from this state we need to make a cycle of 3. So we just transfer the input next a from final to this state. So you can understand 6 is accept, 7, 8, 9 is accept, 10, 11, 12 is accept, 13, 14, 15 is accept. So the states is how much? 7. 7 state DFA is there for this language. The language is regular, that is already understandable. But 7 states are there. Noted. Okay, now let's see. This is the language. A raised to 2 raised to I. The in the power of a, the input is a raised to 2, 2 raised to I. In the power of a, there is a 2. In the power of 2, there is a I. And again, I is greater than equals to 0. Is it regular? Is this is regular? Try to generate the set of a string and give the answer. Let's try to make a set. So this is 7 straight. Now here, is it regular or not? Because a raised to 2 raised to I. Try to make a set. So if we put, let's understand the set is what. Yes, let's check. If the value of I is 0, 2 raised to 0 is what? Let's understand the set. So value of I is 0, then it is I is in the power of 2. So 2 raised to 0 is 1, means single A is generate. If the value of I is 1, so 2 raised to 1, that is what? 2, means double A is generate. When the value of I is 2, when the value of I is 2, actually the input is only A. I is just a variable that identify what is the length of a string. So if value of I is 2, then it become 4. 4 A's will be generated. If the value of I is 3, then 2 raised to 3 is 8, means 8 A's will be generated. 8 A's will be generated. When the value of I is 4, then it will become 16 A's. Means we can say that for 1A, double A, 4A, 8A, 16A, 32A, value of I is 5, then it generate 32A. Not shorted string is not epsilon, because when you put value of I is 0, 2 raised to 0 is what? 1. So that is single A, because I is in the power of 2. So when you put 0, that become 1. So A raised to 1 is single. Got it? So this is A raised to 1, that is single A. Yes. So we need to understand what we need to understand. The point is what is the common difference between this string? What is the common difference? Is there any common difference between the string? Here the difference is 1, here is 2, here is 4, here is 8, here is 16. So there is not any common difference. The common difference is not there. That the string of length means the string set of strings are not follow any pattern. So it does not follow any pattern. Not follow any pattern with common difference. With common difference. That's why this language is not language. So it is not regular. This is not regular. This one is not regular. Clear? This one is not regular. As we already says that if there are more than one input, then you need to check there is any dependency between the input. And the second thing is what? The string, or we can say that this set should have some common difference between the strings. So this is not regular. Now, in the same manner, if I just put L equals to A raised to 3 raised to I, got it? So if you put 2 raised to I, so it will be generate the number of power of 2. If we generate 3 raised to I is greater than equals to 0. So again, in the same manner, it will be generate what? How many number of A's? Like single A, then 3 A's, then 9 A's. All right, because 3 square is 9, 3 raised to 3 is 27. So here is 1, 3, 3 raised to 1, 3 raised to 2, 3 raised to 3, and so on. Means it will be generate that number of A's. So again, not any pattern. So this is not regular. This is not regular. Now in the same manner, I will give you one more example and just check for this. A raised to I raised to 2. I is greater than equals to 0. Now in the previous case, we put 2 raised to I. Here we put I raised to 2. I square. I is greater than equals to 0. And the input is A. Is it regular? Yes, this is also not regular, clearly visible. If we put the value of I is 0, then it will become null. When we put value of I is 1, it is single A. Put value of I is 2, then that 2 raised to 2, 4A. Alright, value of I is 3, then 9A. So it become what? 0, 1, 4, 9, 16, 25, and so on. So again, there is not any common difference. Not common difference. So this is also not a regular language. This language is also not regular. So I think it is understandable that how to check the pattern. Pattern must be clear. Now one more, and the most time asking question in the GATE examination, that is a raised to p is prime number. Is it regular? A raised to p is prime number. Is this is regular? So again, this is not regular clearly, because set of prime number is what? So as we says that one, no, one is not prime number. That 2, 3, 5, 7, 11, 13, 17, and so on. So again, there is not any common difference. So not regular. So I think we can understand that language is regular, which one is regular, which one is not regular. Got it. So it looked like this. Now we just try to solve some question. Yeah. Now check for this. What is the answer of this question? L equals to a raised to I, b raised to k, I is greater than equals to n, and k is between 0 to n. For some n, is this language is regular? That is very interesting question. You can understand the question by taking any example and you can give the answer. The question is what? L equals to this for some n, means it, the question is what? On some value of n. If we take any value of n, some n means what? For some value of n means for a specific value of n, is this language is regular? For some n means what? There is not any range of n. It says that for some n, because in this language unknown variable is what? I is depends on n. It says I is greater than equals to n. Okay, language is regular. Okay, so I is greater than equals to 1 n. It says that I is greater than equals to n and k is greater than 0 and less than n. For some n means what? On some value of n is this language is regular. So if we says that value of n, let's suppose the value of n is 3. If we take any value of n, because it says that for some n, so if we take n equals to 3, so the language is become what? A raised to I, b raised to k, I is greater than equals to 3 and k is greater than 0 and less than 3. So here I is greater than equals to 3 means any number of a's, minimum number of a's is 3, and after 3 any number of a will be accepted. But the value of k is what? Either 1 or 2, because k is greater than 0, less than 3. So now k is constant, means number of b is not depends on a, so it is independent, and number of a is linearly increase. So we are definitely design the automata. So the regular expression is what? For n equals to 3, the expression is what? Triple A. Minimum A is how much? 3. So triple A, after then any number of A's will be generated. So we just put plus on last A. So AA plus, after then either single B or double B will be generated. So this is what? First A, second A, third A, and then any number of a's you can generate. After then, if we read single b, it will accept. If we read double b, it will accept. So this is the finite state automata for this language on n equals to 3. So for some n, we can construct. If we put n equals to 4, it number of state will increase. Here triple, first b, second b, triple b, and here 4, minimum a is 4. So definitely it is what? Regular. So this is correct. Always remember one point. The language is either regular or not regular. This type of option is definitely not acceptable. Means the regular for a small value, regular for large value. So that is not any logic of this option. Either the language is regular or not at all. So this is regular. This is 100% regular. Got it? For some n, if we put the value of n and after checking, that language is regular. That's it. Now the same pattern question. Let's understand. Exactly same pattern question. Just slight modification is there. In place of n, we put here I. So L equals to A raised to I, B raised to K. I is greater than equals to n. For some n. Again, for some n means on some value of n, is it regular or not? I is greater than equals to n. And K is greater than 0 and less than I. For some n. So just take any value of n and check. Is it regular? Is it regular? You can understand. Just take a value of n. If we same, if we consider n equals to 3, because it just try to asking for some n. So here the language is what? A raised to I, B raised to K. I is greater than equals to 3 and K is depends on what? I. But I is not fixed. N is fixed. Got it. So if n is what? Fixed, then here we can say that any number of i's we can generate, but number of b's, as the variable of b is what? K. So k is ranges what? 0 to less than I. So what we can say that I is greater than equals to 3 means minimum value of I is 3, and after then any number of a's can be accepted. But number of b's is depends on value of I. Now I is not fixed, I is variable. So we are not saying that Means we directly says that number of b's is what? It is less than number of a's. As says that k is less than I, means number of b is less than number of a's. So indirectly number of b's depends on number of a, because a is not finite, a is infinite. The range of a is not fixed. So we are not saying that how many a's will be generated. Any number of a's you can generate. More than 3, you can generate any number of a's. So we are not fixing number of b's here. That's why this is not regular. Is it clear, Avik? So this is not regular. So difference between this question and previous question is clear or not? Because here number of a and b are not dependent. Both a and b depends on value of n, and here according to value of n it become a constant, and it will be a infinite. So there is not any dependency. But in this question, number of b depends on number of a. That's why it is regular, not regular. Okay, is it clear? Okay, now let's try this one. Out of this four, which of the following is regular set? Means regular language. Some of them we already discussed. What the answer of this? We already write down many of that. First, second, and third we already discussed. In the first one, it says that n is greater than equals to 0 and m is greater than equals to 0. So obviously number of n and m are independent. Means we can say that this is a star, and number of b is what? Twice of m, means double b whole star. So any number of a's and even number of b's, that is 100% regular, because number of a and b are not depend to each other. So this is regular. First one is regular. So three options are there. Last one is rejected. So either first and fourth, either first and third, or first only. So nothing is about second. So don't need to check second. It is clearly visible. N is equals to twice of m. Actually, in the option second is not present. So there is no need to check second. Don't waste time on this. But it is clearly visible. Number of b's, number of a is just twice of number of b's. Got it? So there is a dependency. So it is not regular. Now here number of a and b should not be equal. So this is also not regular, as we already discussed, because dependency between a and b. And the fourth one is what? X, C, Y. So here the option is already rejected. Got it? This two option rejected. Now either first four or first only. So in this X, C, Y. So in place of X, you can put A plus B whole star. in place of y you can put a plus b whole star, and there is not any dependency between x and y. X and y are independent. That means what? That means here it will be a single input c, it reaches to a final state. Before that any number of ab, after that any number of ab. That's it. This is the regular. So first and fourth both are regular. A is right answer. The option is A. A is perfect answer for this question. Got it. So this is the languages, different types of languages that we discuss. Now here we need to understand in tomorrow session what we discuss. That is all about today. Tomorrow we discuss the some more question on regular language. After then closure property of regular language, that is very important. Closure properties of regular language, that is very important topic. So regular language, closure property of regular language, and after then there is one more topic that related to regular languages, Mille Mure machine. After then our regular family will finish, and then we start the context free grammar. So the largest topic of theory of computation is what? The regular family. After then context free grammar, means we can say that 60% is regular family, 20% is context free, and means 25% is context free, and 15% is the last Turing machine, and so on. Okay, so that is all about today. Bye bye and good night.